Okay, so this is an opportunity for us to have a discussion, not only about what they talked about, but what the future may represent. And this is what I found most interesting at these conferences, where you get to pick the brains of some of the people who have been doing the work in the trenches and what they may think is an appropriate course of action that needs to be studied next. Okay? So I'm going to moderate. If you have questions, let us know. You can pass them over to Diego or somebody to bring them forward, or you can put it on the chat. But I want to open up with Dr. Wallimann. After doing this research for 50 years or so, what do you think needs to be done, and what is the potential, the greatest potential for human health and well-being as we move forward to the next 50 years?
Considering that creatine supplementation is favoring even healthy tissue like muscle, bone, brain cells, I had long in my head an application to skin. I didn't talk about that. Skin expresses a lot of creatine transporter and creatine kinases. And around the world, Children's Hospital and burn clinics try to cultivate skin in big flats. They can grow from fibroblast skin flaps and transplant it to the burn wound. And I would definitely suggest that for growing such skin artificially, one should add creatine. I have paddled around in Switzerland at some clinics, no response or no real interest, but I think these skins will differentiate better and they will be more suited to really then adapt to the wound for wound healing. Also, I would propose that people in the transplantation clinics for heart and kidneys, that you would preload the recipient of a transplantation by high doses of creatine, and that you would perfuse the heart or the kidney to be transplanted with creatine to give a better state of energy and a better protection against these obnoxious conditions, storing the organ for hours. I think that would be a feasible project to grow.
Okay, so the same question goes to Dr. Ostojic. What do you think needs to be done to advance the field?
Thank you, Rick. I think two aspects should be addressed in the future. The first one, we have to think about creatine as a semi-essential nutrient. So not just as another supplement, although we have plenty of good data, but let's try to build a little bit different set of evidence and more robust research really to find out, is it essential or semi-essential or non-essential? We did some preliminary studies suggesting that infants from 0 to 12 months definitely need creatine for brain growth during the first 12 months of their life. So it's definitely essential for this most sensible population. So I think all of us should think about creatine not as a dietary supplement, but a fundamental nutrient. This is the one agenda that also is related with population-based research. So much more data should be collected from NHANES, all of us, UK Biobank, really to support the information about creatine for the general public. This is the first area I can see is coming, and we already, and some other groups started doing the research in this direction. The second area that I think is also very important and interesting is to scrutinize probably novel creatine formulations required for brain-specific conditions. Because all of us here, or most of us here, has some experience with dealing with brain conditions, huge dosages of creatine, some effective, some less effective in terms of the pathology. But I think, and I discussed about that with Mauricio recently, maybe we have to really try to embrace creatine precursors and maybe some molecules that are not going to be transferred to CT1 receptors, but they definitely will improve the level of creatine in the brain. And I think this would be also extremely important to provide a feasible low dosage intervention that will improve the brain for many different populations. Thank you.
So let's jump back to infants, and then we'll go to adults, elderly. Then I want to have Dr. Stout, after being involved in the creatine research from the early days. What's your perspectives? So Dr. Ellery.
So what's my perspective on it for infants? And children. Excellent question. I'd almost say if everyone can hang around until my other presentation, or third presentation, on Saturday afternoon, I'm going to be presenting some of the preliminary data from a cohort study that we did in preterm babies called our Unicorn study, focusing on precisely that, the need likely for exogenous or dietary creatine in those first crucial months after birth up until 1 year. And particularly for our preterm infants who likely don't get the levels of creatine they require from mum during gestation because they come out too early. And they often, especially when they're being cared for in hospital, they're managed on TPN, other nutritional supplements, I guess, as opposed to breast milk or formula. And so there's this real coming together or perfect storm of circumstances which mean that these babies might not actually be obtaining the amount of creatine that they are requiring, especially during this huge period of brain growth, and we know how important creatine is for neurological development. And so I'll be going through some of that data on Saturday, but the short answer is yes, this is a critical population that we should be focusing on in terms of creatine supplementation. It's not one that we've been focusing on to date, but yeah, we should be giving it a lot of attention.
Quick follow-up. Do you see creatine potentially being the next folate for pregnancy? No controversy there.
Yeah, I mean, that's certainly the way we position it when we're talking to people, particularly just out in the community, because it's an analogy that is easy to digest and to understand. It certainly wouldn't be quite as easy to implement as folate. Folate's 2 milligrams per day. You can easily shove it into other multivitamins. Having said that, there is growing data, not just from our laboratory, but also looking at population studies that suggest that creatine metabolism changes, obviously across pregnancy. Also, it often is flagged with pregnancy complications because most of them are really driven by changes in oxygen and nutrient delivery, either to the placenta or to the fetus itself. And so it's a really primed environment for a nutritional supplement such as creatine to have some beneficial effects. And the counter-argument is that creatine, being a nutritional supplement, would actually be quite easy to implement. I think we just need to get the dosing right. We need to make it as straightforward as possible, and we need to take pregnant women and their families and the community along for the ride in terms of reassuring them that we're getting as much safety data as possible through all of our preclinical studies, and being able to come to them with a really robust reason for taking creatine during pregnancy.
So it's the same question for Dr. Candow, and before I pass it on, it's a personal anecdote. I had my daughter-in-law on creatine during pregnancy, and she had stepped off a curve and had a placental abruption, and the doctors were concerned that she would be able to do natural childbirth because of ischemia and asphyxia situation. The baby came out looking like Arnold. I mean, amazed the doctor how capable he came out, and amazing. So I'm a believer. Okay. Dr. Candow.
Same thing, like applications for elder, or So I think a few things. We touched on the clinical aspects. I think we know the health aspects. We really need to do a better job at progressive dosing strategies. We're always looking for the lowest, safest dose. My argument is, why don't you look for the maximal safest dose? Because a lot of the errors in our studies is like if we gave a bit more or longer. So progressive titrating dosages which need to be done. We still have no clue on the optimal dose. You've seen the range from 3 grams all the way up to 35 grams. We still don't know, especially as we get older. Do we have anabolic resistance to creatine, very similar to protein? So that's the area there. And I think the other one is to focus on clinically diagnosed populations for healthy aging, getting into the old with frailty, cachexia. We want people to live longer free of disease. You don't want to live longer with disease. And if exercise and this compound can help, which we all think it can, and the evidence is behind it, I think those are the areas there. But it was amazing with Stacey's. It's the evolution. We've gone now to fetal development, right up to centenarians with this compound. So I'm really excited to see where it's going. And who would ever thought from the brain or the neck up? And now that's a big focal point, right? So I think it's a whole body dose. I take about 10 grams on average a day, and that's even changed for a creatine researcher from the 3 to 5 for muscle. I've even doubled my dose based on science. And again, Rick has an amazing paper coming out on safety, and it's the safest, most effective ergogenic aid, even above caffeine now at recommended dosages. And I think we can go a bit higher. And the other big area I'll finish on is someone is eventually going to come out with a liquid stable creatine, which I think will be foundational for older adults to grab the drink. They can walk their dog, sit at home, and it's easy to deliver instead of the powder. The powder can be advantageous with chewing issues or things like that. I think if a company finally gets a stable creatine, it's going to be a game changer for older adults from a chewing perspective, digestion, GI tract irritation. So I think that's where it's probably going. I know there's a lot of help and potential there. It's way out of my brain. But I think if you could get my grandparents to grab a ready-to-meet drink that actually has like muscle, bone, and brain on it from a marketing. I have no idea why creatine's not in Greek yogurt in the grocery store. It's like, it's stable in solid, but it's solution. So I think that's where it's going. And whoever does that, it's going to be a game changer. So that's where I see, especially for older adults, yeah.
So let's move to Dr. Stout, and he's one of the individuals when we started this research with Dr. Harris, myself, and others, we're told, why waste your time doing research on creatine and dietary supplements? It'll hurt your career. So with that perspective, tell us what your perspective on where we need to go in creatine.
Well, it sounds like we're doing it. All the research I heard today is fantastic. You know, in 1992, Dr. Roger Harris was interviewed by The Guardian during the Olympics. And during that sort of quotation, he had said, originally, we didn't want to help sportsmen. We wanted to use it clinically for the elderly. So we have Dr. Candow, even though he's on the super high dose that's probably going to blow up his kidneys and cause him to go bald, he's doing really good research, right? And the thing I think is missing, and I think is beneficial, because I did it with my own kids, is kids from the age 5 all the way through adulthood. We're already talking about children. And I did that with my kids. I saw a huge benefit. And one other thing was this preventative potential concussion or TBI. I think is very important for athletes. We actually got our physician for our athletics, our football, to prescribe, because in the United States, you can't give creatine to football players. So we got the physician to prescribe after we showed them enough data that this could be a safety issue. And so now all of the football players are taking creatine. So I think more research needs to be done on that area as well, along with kids, and then continued research on elderly and then different diseases. Another thing we were talking about earlier is that when I was a young professor at Creighton University back in mid-90s, I had another researcher. He did research in fruit flies, genetics, and he had claimed that my creatine research was going to cause muscle cancer. And I thought that was interesting because now we're having research on potential benefits of creatine with cancer. So full circle, that's been my life on creatine and how it's progressed, and it's just amazing what all you guys are doing as far as your research.
So my experience was when we first did our paper, so it came out and showed it increases muscle mass. in athletes doing resistance training. It's like impossible. It has to be water because it couldn't be that much of a change that quick. And I remember a very prominent physiologist being quoted in an article saying that they felt the people pushing creatine, or at least doing the research on creatine, would be found to be scam artists and pillared in the scientific literature for doing research. It takes mavericks to do the type of work. And what Uwe Slotner said earlier about you have to ignore, and the same thing, you have to ignore some of the critics because that's how you move science forward. So with that said, Dr. Wallimann, you mentioned providing creatine in, before surgery as a way to enhance the availability and metabolic activity. There are studies in animals that show if you have animals fed on creatine diets and you cause a stroke in the brain or cause ischemia in the brain or cause a traumatic brain injury, that the size of the damage is significantly less. And you showed us a little bit of data on maybe the vascular system may be related to increase in blood flow. Do you think that this is going to, back in the 70s, actually gave in IV fluids creatine to heart patients to try to reduce arrhythmias and things during ischemia? Do you think that that's the next phase clinically, in addition to just reducing the chronic disease, maybe actually pre-operation loading people with creatine so they withstand the surgical intervention better?
Yes, I think this will be a big area. Like for heart infarction patients, you should give creatine intravenously in high doses so it reaches really the heart. Or with preemptive hip surgery or bone fracture, you could give creatine early upon operation or even before, if you know when he's going to be operated, and then give it during the whole rehabilitation process, of course. I think that's a big thing to do, but I tell you, to convince orthopedic surgeons and doctors to do this will take another decade, I think, I predict.
Which is why we're here, to try to help educate. So, Dr. Ostojic, you're MD. Yes. Would you give some perspectives on that?
That's an excellent question, yeah. You know, I'm going to talk tomorrow about a little bit different approach that would help us to reach the community. It's a kind of public health approach, and that requires more rigorous type of research and design and methods, also regulatory issues. Because I think this is the new frontier for creatine. We already have a nice information on exercise science, some information on clinical medicine in general, but this public health agenda is the next big thing. Because, you know, when you go to the clinical nutrition symposia, particularly here in Europe, but also in the US, most of the medical doctors somehow don't know enough about creatine, but they are, the creatine is stigmatized for this population. So although we could easily explain this is not the case, we have to convince them by using their tools. So by publishing papers on creatine in important journals that those guys are reading, guys like me, you know, MDs and stuff like that. So instead of I'm going to put a kind of invitation or call to everybody really to embrace that general public health approach in their communications. Abstracts, you know, papers, media communication, embracing the idea of essential nutrient, something that is very safe, even if provided in a long-term type of intervention. And also, you know, in my opinion, it's very important to stick to the critical sensitive population, such as a pregnant woman, women who are lactating, and also the very young children. And we already have a very nice set of data, some from my lab, using NHA's data, some from the Stacey lab as well, that creatine is very effective and very safe in this population. So this might be put on the frontier of this new approach, you know, instead of very good data we have on exercise science and clinical nutrition. Let's see, is it creatine good, only creatine, without resistance training for the general population? Is it safe? Is it efficacy enough? So that is why I suggested Alzchem people a couple of years ago to attend the Clinical Nutrition Aspen, the biggest conference in the world in terms of nutrition, And maybe Robert could share some of the responses from clinical people, clinical nutritionists who approached the booth. It was, I don't know, in Milan or before Milan. Yeah, Lyon, exactly. So it's different. So we need to step into this new reality of people who are doing different type of populations who assign nutrition for critically endangered people. So I think the Professor Theo suggestion, to embrace that approach for the kidney application of creatine, that would be something that is really helpful to spread the idea further. Thank you.
So one of the points you raised earlier was maybe we need to look at this as a diet approach and maybe as a functional food, that if we add creatine into commonly consumed foods, that we can increase the dietary availability, because the NHANES data, if you're a child growing up, you don't grow as fast, you're shorter, you have more body fat, you have less muscle mass. If you're a young female and menstruating and through puberty, you have more issues if you don't have a high creatine diet, all the way through aging, where it can actually have better cognitive function as you age. And so the question is, how can we get creatine into the regular diet? Maybe it's not just supplementing to make sure. Maybe we need to have a gram added to certain type of foods. Anybody have a comment to that?
I will for sure, because I'm not going to go into too much details. I prepare a presentation for tomorrow exactly that is going to answer this question. But thank you, Rick, for that. Functional food approach might be very important in this area, and somehow we have to consider creatine like we considered other semi-essential nutrients like choline, for instance. 30 years ago, choline was outside of the scope in terms of the general population. So I think that following the scenario that choline researcher did for choline, eventually recognized as a semi-essential nutrient, and everybody, any MD will, take a look on the CDC or NIH guidelines and see, choline is there. We know the recommended dietary allowances for kids, for pregnant women, for elderly. That kind of approach, suggesting that creatine should be consumed primarily from food sources, and NHANES data suggests that 65% of US population doesn't consume enough creatine. So that kind of approach would help us a lot with appropriate functional foods such as breakfast cereals or dairy sources, something like that. Thanks.
Yeah, I'd just add to that. I think most people know the benefits of protein, and there's three studies I can think of that have looked at a synergistic effect of creatine and about 25 grams of a complete protein source. So when you're looking for breakfast, which is the most important meal of the day to stimulate mTOR, lunch is kind of irrelevant, and then you stimulate it again later on in life. That breakfast, most of us skip. That's a big error, and a lot of older adults skip that. So if we can emphasize food approach first, but having a higher protein breakfast with maybe creatine there. So I do the exact same thing in the morning. I put 10 grams of creatine in a high Greek yogurt type of breakfast. It's easy to do, but that's a food-first approach. But there's been some good data that looked at the synergistic effects of creatine in young individuals and older, and I think those two compounds, obviously protein. So if resistance training is the cake, protein is the chocolate icing, and then creatine will be the sprinkles on top to convince people to consume it a bit better. And I think if we can get more emphasis, all your papers on the NHANES data and the minimal amount of creatine, these are things that it's up to us to get out there, and I think we're doing it. But I mean, I did 30 podcasts last year, and every single podcast says, why is creatine causing my kidneys to fail? Because I have increasing creatinine. And I'm like, I don't have any more hair to pull out. And I said, well, we can talk forever about it.
I think.
Yes. Robert, do you have a question? Yes. Here. I'm doing my Oprah.
Thank you. Well, I would like simply to add something from, being out in the fields, and based on that, what Sergej has been saying. What we experience when we speak with MDs out in the field is that their knowledge is based on what they learned 20, 30 years ago. And they are not ready to move that. For them, it's still anabolic steroid, bodybuilding stuff, and they hardly go beyond that. So to overcome this, it's so important what Sergej said. publish, do abstracts, go to magazines. If we can be of any help, let us know. But this is so important because you really have to change a mindset. That's one part. When we speak about food, we have been speaking with many people, and especially when we speak about vegetarian populations, we see very strong, very good effects of creatine there, and everyone knows why. The problem is, if you speak with the food producers, they will tell you, well, it has no smell, it has no taste, it has no texture effect, it simply makes my product more expensive, so why should I put it in? And the problem is that they say, well, simply if I write creatine on my jar or my box, no one will know it. If they know it, it has a negative connotations. So again, here the important thing is, I fully agree with functional food is where it makes most sense, but we have to explain the function first. And again, this is coming back to what Sergej said before. It's very important really to educate, to enlighten, to share information. I've been thinking when you came with the kidney thing, like everyone here was, oh no, not again. But that's what we see out there. So really keep on writing, keep on publishing stuff. Again, if we can help, it will be our pleasure. And yeah, that's what I would like to add to that. Thank you, Rick.
So I have one more question before I'll open it up for the audience to ask questions or people online. We talked earlier about obviously the potential, lots of benefits of creatine throughout the lifespan. But there was also mention of other nutrients, things like essential amino acids and other things that we know can help in aging, improve or prevent loss of muscle with resistance exercise. So if you're putting a formulation together for all the folks out there that are thinking about doing this, what would you include if you're looking at active aging and preventing decline? You know, we're doing exercise, high protein, creatine. What else would you add to that? Let me start with Jeff Stout.
Vitamin D3. I think that what we found in the last decade was vitamin D actually enhances the benefits of other types of nutrients, including creatine. I would add the protein aspect of it, making sure protein is with it, and then creatine. I think one of the things with creatine, getting back to the importance of making people understand what happens when we don't get enough creatine in our diet. And I think when we can explain that, and when I tell my relatives who know nothing about creatine, it's a population health sort of issue, and the reason people don't even think about it. And another thing is in the United States, there's this promotion for veganism. There's a promotion for these diets that don't have creatine in it. So these kids are having lower than normal creatine intake, and you're seeing this kind of weird sort of development. So I think we need to push. What happens, like when we're low in vitamin D, there's clearly things that happen. We're low in vitamin C, those kind of things. I think the approach needs to be, what happens if you're not getting enough creatine in your diet? I think we do that, and then everybody's like, oh, well, I'm going to have that bar that has some creatine in it, or I'm going to have that yogurt that may be spiked with some creatine. So again, to me, vitamin D3, a lot of people don't realize, I get mine tested once a year to make sure I'm at that 50 range, in order for everything to be optimized. But that and creatine and protein, I think, are the most important ones.
Dr. Ellery, same question.
Yeah, well, I mean, vitamin D is a massive area of interest in pregnancy as well. We see some huge changes in pregnancy outcomes associated with vitamin D deficiency, so that's definitely one up there. And again, in the pregnancy space, arginine itself, L-arginine, incredibly important for placental function. We see real significant changes in fetal growth when L-arginine levels aren't as high as they should otherwise be. I could keep going on and on. So methylation, obviously DNA methylation, cornerstone of the development of any fetus. So having enough availability of methyl groups is really important too. So there's a combination of different nutrients and amino acids that could potentially be packaged together with creatine to help with pregnancy outcomes. Having said that, we're really at the early stages of what would that look like in terms of composition of such a multivitamin. How much do you need? Is it the same for all populations? And so we've kind of taken a little bit of a similar approach too, of looking at just a healthy population, but are there some key maternal characteristics or pregnancy challenges which are associated with changes in creatine or with changes in arginine, glycine, methionine? And what do those changes look like? How do they direct outcomes as a starting point of how we could potentially use supplements to improve things? So there's, I guess, the two angles to it. It's, you know, creating those super physiological levels to help with the incidences of hypoxia, ischemia, and those sort of sentinel events that we can't really, or it's challenging to predict. But then that idea of, are there some conditionally essential nutrients that we're not really across in pregnancy just yet? What do they look like? Which population should we be targeting? And what should we be giving them? So there's a lot to do, but...
So while we're on that side of the table, Dr. Wallimann, are any other nutrients you think that might enhance creatine action or creatine kinase activity?
Probably omega-3 fatty acids I would recommend. I take myself also. I wanted to say some remarks to Robert Albert, how to educate medical doctors. My daughter is an internist, general practitioner, and they see 40, 50 patients per day. They have no time to read. So don't think you can approach an MD in a praxis to get some new stuff out. They learn at regular meetings from professors or clinic directors, and they tell, take this, do this, do this, and they take it for granted. So we have to approach these guys who go out and teach the practitioners, and I think that's the biggest thing to do.
This sounds so trivial, but in my experience dealing with MDs, is that they actually don't often know the difference between creatine and creatinine. Creatinine is so embedded in their brain as such an important component, especially for general practice and general medicine. They're looking at that every day. It's one of the main things that they'll test in blood for any condition. And so getting information out there to allow doctors to discern the difference between creatine and creatinine is a really important one. Even the practitioners that I work with that are research active, that have been along with our creatine journey for decades now, you'll be sitting in a meeting and they just can't even bring themselves to say they automatically say creatinine, even though they are across all of the literature. So I think there's a lot of awareness that needs to be built there around the difference between the two molecules, because at the moment we're behind the 8 ball when it comes to even that simple and somewhat trivial sounding issue.
Great point. Huge issue. So let's have Dr. Candow next answer.
Geez, I definitely agree with everything that's said. I think with the protein, the leucine spike, it's something to be there, but that's so hard. The other areas I think for the future is looking at the combination for healthy aging with collagen or probiotics. I think that's something to consider, but I agree the omega-3 is one that I take quite a bit. And the other thing for the audience is please don't think you always need carbohydrates to get an increase in creatine in the muscle. That dose is about 100 grams. Mark sitting there, they showed that protein is gluconeogenic. I would strongly recommend to take creatine with protein compared to simple sugars, and that's a big avenue of concern for a lot of people. The dose required is right high, and I think from a population health perspective, getting away from these ultra-processed carbohydrates are not needed. A lot of people think you do, and going back to the creatinine, the EGFR is a great way to measure kidney function, but if creatine is broken down, that creatinine is always there, and it's something that often gets above. But those are the only other ones I could think of. I love the protein omega-3 blend. I know Mark's done stuff with alpha-lipoic acid, but these are ingredients to get in there and upregulate, but they're hard to put in a natural food. But it'd be great from a food-first approach. A lot of people might not know that it's in seafood or red meat, or if we can get in other areas, it'd be fantastic. You'd have to drink all the milk from a cow, to get a substantial amount, but a salmon steak tonight or wherever we're going for dinner, maybe there's going to be meat there, and you may not even know that there's creatine in it, so awareness from the public is a great tool. So, yeah.
Dr. Ostojic.
Thank you. When you answered the last, it's really easy to find something that is left from this story. So basically all the important components, including the medical group donors or probiotics, might be important to add to the creatine. But in my opinion, we have to think probably as creatine to be most deficient of these nutrients. And I like to highlight again the fact that we should consider the creatine malnutrition as something that is really, really relevant and affecting so many people. So all these nutrients are very important, and we are paying particular attention to this because my department in Norway is dedicated to first 1,000 days of life as most important period of development, and we just addressed that in a special issue last year in the journal. With creatine might be something that is particularly important to address one more time. So creatine malnutrition, not creatine deficiency, but creatine malnutrition might be something that requires much more attention from our community in general. Thank you.
So what we're working on at Texas A&M is active aging. And so if you're looking at growing older, your muscles get weaker, you lose muscle mass, your memory declines eventually. And so we're countering that with a series of studies to try to find out what that nutritional cocktail may look like. So it starts out with good exercise with resistance training. That's the key. Keep muscle mass. Then enough protein in the diet, or maybe timing post-exercise protein with lots of essential amino acids. Then we're doing our first study with creatine. Then we're going to add quantity of acetic acid, small amount. Then we're going to add antioxidants, omega-3s, and we're going to add anti-inflammatories, like curcumin and other things. And we're not only looking at we're actually recommending to the military that they provide creatine, omega-3s, and anti-inflammatories for the military because of the susceptibility to head concussions and those type of things. So I think that's kind of where we're going, at least from our perspective, but it'll be kind of creatine's essential, the base, and then what else can we do to help protect the brain? So if you're a formulator out there, I just gave you some opportunities to develop some products in the future for active aging. All right, do we have any questions from the audience? Yes, Tim Zugavus.
Thanks, great first day. I just want to echo the comments that have already been made about the additional nutrients that might complement creatine's effect in the body, whether it's skeletal muscle, brain, or bone health. And it was mentioned once by Dr. Candow, probiotics, right? We know from data on protein, recent data on protein, that if you combine certain probiotic blends with protein, you get an improvement in bioavailability of the essential amino acids. So I think if you're looking at a middle-aged to older population that may have some absorption issues, and you're giving them a certain dose of creatine, you have no idea if the bioavailability of that creatine dose is the same as what's been reported in the literature since the early 90s, right? I think there's maybe one or two studies. Dr. Tarnopolsky may have done one. He can comment too, but no-brainer for me to combine creatine with a high-quality probiotic blend because you may see improvements in systemic bioavailability. And then finally, maybe magnesium, because we know people in the US don't get enough magnesium. Magnesium is a cofactor for ATP hydrolysis. Doesn't mean that if you ingest it orally that it's going to work like that, but I still think there are a lot of health benefits for increasing magnesium intake.
Dr. Balestrino?
Thank you very much. I'd like to ask two questions, if I may, one to Dr. Wallimann and one to Dr. Ostojic. To Theo Wallimann, I would like to ask this thing. You said that creatine is good because it picks up phosphate from ATP at a mitochondrion level. Then, if I understood well, the mitochondrion works better because it has a higher ADP to ATP ratio. But I remember in one of your first slides, you showed that the ADP actually blocks the production of ATP. So it seemed to me that there was maybe a contradiction between these two things, and I would like to ask you this. Maybe I didn't understand very well, but in that case. And to be quick, to Sergej, I would like to ask this one, just to play devil's advocate. Speaking of giving creatine to all normal people, because most normal people is, as you said, malnourished on creatine. Should we not also remember that creatine is synthesized in the body? So if, even if many people do not take enough creatine, we should remember that creatine is synthesized by the body, and that is, for example, brain, relies mostly on endogenous creatine. So what do you think about that? Thank you very much.
Okay, about your question in the probably you got me wrong. In the mitochondria, ATP produced by OXPHOS, right, is channeled into the mitochondrial CK, and creatine from the cytosol is then producing ATP, and the ADP directly goes back to respiration. So ADP stimulates respiration, of course, doesn't inhibit, together with creatine.
Thank you for your question. Of course, we are synthesizing some creatine, and classical paradigm is that we get half from the diet and half from our own body. And we did plenty of studies. Some of them are currently ongoing to try to calculate how much actually is provided from the endogenous sources comparing to exogenous sources. And I published a paper a couple of months ago in Nutrition Reviews estimating how much creatine is required for a kid from 0 to 6 months, depending only on breastfeed milk. And it appears that it's not able to synthesize all it requires, so any kid has to get something from the diet. And probably 90% can be synthesized, particularly for the muscle and the brain development during this first 6 months of life, but 10% probably a little bit more should be consumed from the diet, suggesting that creatine is essential nutrient. So a kid who is not going to get that by mother milk have to get it, should get it through the dietary supplements from some other sources. This is the reason that should be always scrutinized by studies in different populations. But my approach regarding the general population is to stick to the really to estimate what are the dietary needs. We don't know a lot about that. So far there is no recommended dietary allowances for creatine, except for that in the youngest population. I think our average person might require a little bit less than 1 gram per day, just for a normal homeostasis. But it might be a little bit more in some specific population, like elderly or kids that are growing. So yes, we are synthesizing something, and my student and me just completed the data analyzing what appears to be the sources for endogenous synthesis coming from glycine, arginine, and methionine, comparing to dietary exposure to creatine by itself. And we just submitted that paper last week to European Journal of Nutrition. So I might be able to address a little bit more about that tomorrow after my second presentation. But it is extremely interesting. And in my opinion, it changes a bit a paradigm that we embrace for, 30 years, that half-half is a formula. It's a little bit different. So maybe we could dig a little bit deep into it after tomorrow's presentation. Okay?
Yeah, and I will add one more point to that, is if creatine synthesis alone was sufficient with just normal dietary intake, then creatine levels in muscle and other tissues would be at 100% all the time. And it's only typically about 60% unless you increase dietary availability of creatine. So that kind of argues that you probably do need more than what your body can synthesize on its own and with the typical amount in the diet. And if you go a long time back in history, some of our ancestors ate very high meat and fish diets that had a lot more creatine in the diet than we typically get, about a gram or so in our typical diet in the Western and Eastern area.
Yeah, one point to that, the vegans, they're probably using the maximal capacity to synthesize creatine from endogenous sources, and they're not building enough creatine. So the levels in the muscle are lower, suggesting that it is not possible to do it without getting some exogenous creatine from dietary supplements from the diet.
So I've been, one more question, I guess. Go ahead.
Okay, I just scream, thank you. Hi, thank you, Peggy. I'm not a scientist, but I'm working with a lot of doctors. So the question is, is there a blood marker that you can measure creatine in the blood? Because if you're supplementing for 10 grams, so I also have a brand, we're producing creatine. So people ask us, like, how much do I take? How can I measure it? So is there a blood marker where you could, like, as a doctor, take a blood test and then you see, okay, like with vitamin D3, so you do your creatine test.
You just actually measure creatine in the blood. Is that what you mean? Or yeah, you actually can measure creatine and creatinine ratio in the blood. Yeah, easy.
So it's an easy test. So actually, it could be done with any checkup with your vitamin D3 level.
They don't like to do it. They can. It's like you actually getting a doctor to measure APOB now or C-reactive protein. They don't like to, but they'll add it. But creatinine is measured on any blood requisition form. They can easily.
But it's the kidney, right? Or
that's how they falsely justify that there's something wrong, and then they go off creatine, and then the creatinine levels come back to normal. But if you're asking if I'm correct understanding, can you measure blood creatine? That's how we all determine it in the blood.
No. I know, because this is what always confused, right? So if they measure, so if you're supplementing creatine, can you measure at some point this is an optimal level for you, or that's how you increased it? Sorry.
Then you got to look at the clearance rate. There's only two areas that we think it's muscle or kidney. We haven't considered the brain or bone yet, so it'll peak, but then you're measuring the clearance of the two. So you're sort of measuring the time to C max, without measuring too much science, the peak, and then how long the area under the curve is. So normally it clears from the blood in probably about 6 hours with a 5-gram dose. So you can measure the rate that it gets in your blood or decrease. But Roger Harris in 2004 actually published a study where he suggested we should do these micro dosing, about 1 to 2 grams every few hours, and you'll maintain a better plateau than actually spiking and clearing. So I don't know if I answered that. Anybody else? 1 gram every hour, yeah.
Yeah, you certainly can measure creatine in the blood. It does peak in about 4 to 5, about an hour to 2 it peaks, and it starts to dissipate 4 or 5. So if you're taking 5 grams, you're going to see that peak. But what happens a lot of times in your blood work is it's a 12-hour fasting value. And so in 12 hours, it basically goes back down. So I don't know you can just measure blood unless you did a pharmacokinetic. We really need to get to the muscle. And we've actually been talking with the military to try to figure out a way we can measure muscle creatine content in a apparatus, almost like a mini MRS type of a system, where they can then evaluate really is the tissue level lower. And so that needs to be developed. Robert?
Well, maybe just adding to the question of Peggy, I think what you mean is there an easy test for consumers to say, oh shit, I'm low on creatine, I should take some? And then, of course, and please correct me since I'm not technical neither, the thing really is that blood creatine is a measurement for the amount of creatine in the blood, full stop. But this does not mean that it's steadily available in the body. For that, you really should go to the muscles. That's a test people usually don't want to make 2 or 3 times a day.
So going back to the possibility of a non-invasive sort of test, of course we have our MRI method, but that's too expensive. Actually, one method, possibly, it needs to be developed and validated, is through phase angle. And there's been 2 studies now that have shown when you're creatine loaded, phase angle changes. So there's something there within the muscle cell. So I'm just putting it out there, something we may want to look at, because I agree, if somebody can stand on a scale and it says your phase angle is 5, you probably need the exercise, have a better diet, and maybe creatine.
And I'll add, since nearly all creatine is absorbed into muscle, one of the easiest ways to measure creatine uptake is a 24-hour urine sample, where you measure creatinine and creatine in 24 hours and know the dose. So if you gave 10 grams and 8 grams gets urinated out, then you know the body's retained 2, and that's probably enough to maintain. On the other hand, in our larger athletes, in our football players, it took about 10 grams to maintain their values within 1 to 2 because they're absorbing everything because they had so much muscle. So that may be an easier way to do it, but you'd have to have a special requisition, somebody willing to pay the extra money to get it done. Okay, we're out of time, folks. So thank you so much for joining us, both in person and online. Hopefully this has stimulated lots of thoughts and emails. Put down hashtag Creatine for Health, send out information. We want to get the word out about the conference, and thank you so much for your attendance. And we look forward to seeing everybody tonight for dinner here. Sorry, folks online, you missed out. And if you're, tomorrow we'll see you 10:30, I believe, 9:30 Central European time. So set your clocks. We had people way back in Canada emailing. They were up to watch the latest in creatine. So thank you very much, and give our speakers a hand.